Now we have time. I'm so sorry that there was a problem in the last live. We are now going to continue with our questions and hope we are going to benefit from this live. I want to be sorry for that. Before starting, I want you to let me know whether the live is clear. Now, let's continue with the question. Our question was, it was this. The question was to integrate the integral of x power 1 over x power 3 minus 1 dx. We started by factorizing x power 3 minus 1 as you see it here. Okay. Now, let's continue by finding the value of a. I told you that to find a, we can use the cover-up rule. The cover-up rule is applied as taking the limit as x approaches. Before finding the limit, I told you because the denominator of a is x minus 1, we need to hide this in this expression. That's why I'm going to hide this. I will stay with 1 by x squared plus x plus 1 dx. The hidden stuff must be equated to 0. X minus 1 to 0, x will be 1. So here x must be approaching 1. That is, replace x by 1. Here is 1 power 2 plus 1 plus 1. This is 1 over 3. Okay? Hope you are getting that. The problem is, how are we going to find B and C? As you see, the partial fraction of this will be 1 over x power 3 minus 1. This is a by x minus 1 plus bx plus c by x squared plus x plus 1. And we know what a is. Our a is 1 over 3. So replace 1 over a by 1 over 3 here is 1 over 3 by x minus 1 plus bx plus c divided by x squared plus x plus 1. We need to put this on common denominator, which will be the product as this. This must be multiplying here, and this multiplies here. Here, 1 by x power 3 minus 1 is going to be 1 over 3 into this. X squared plus x plus 1 plus bx plus c into this x minus 1 by the product, which is x power 3 minus 1. We need to continue and do it fast. Very, very fast. Okay. Now, let's multiply here x power 3 in the right hand side will be 1 over 3 x square. We are multiplying by x over 3 plus 1 over 3 times x plus 1 over 3, okay, plus this multiplies here bx times x, that is bx power 2, minus bx when this bx multiplies 1, plus cx plus c. This must be 1 because here I can simplify denominators. So I'm going to rearrange. Starts with x power 2. Here is 1 over 3 plus b times x square. Starts with x. I add this as x, 1 over 3 minus b plus c times x plus stuffs independent of x. Here is 1 over 3 plus c, and this is 1. The independent term of x here is 1, that of x is 0, and that of x square is 0. Okay, now this must be equal to 0, so it must be equal to 0. 1 over 3 plus b must be equal to 0. And this also, it's very sufficient for us to find c using this. 1 over 3 plus c, this is 1. That's why c is going to be 1 minus 1 over 3. And here c will be 2 over 3. Hope it's somehow clear. Now, what I'm going to do is to replace a by its value, b by its value, and c by its value. Okay. Here, b must be minus 1 over 3. So let's continue with the question. Integral of 1 by x power 3 minus 1 dx. This is going to be the integral. Our a value is 1 over 3. That's why I'm going to have 1 over 3 divided by x minus 1 here, dx, plus the integral. Our b value is minus 1 over 3 times x, while our c value is 2 over 3 divided by x square plus x plus 1 dx. This will be, I need to take 1 over 3 out of integral sign to stay with the integral of the reciprocal of x minus 1 dx. And here, let me take minus 1 over 3 out. Minus 1 over 3 times the integral. Here will be x minus 2 divided by x square plus x plus 1 dx. The technique that is going to be used here, you see the derivative of this denominator will be 2x plus 1, while above on numerator we have only x minus 2. What we need to do is to multiply 2 on both numerator and denominator. Here is 1 over 3. Since the derivative of this stuff gives this must be the natural log of x minus 1. Minus 1 over 3. Let me multiply a half into On numerator, I'll be multiplying 2 into x minus 2 by x squared plus x plus 1 dx. This is going to be 1 over 3 ln of x minus 1 minus 1 over 6 times the integral here will be 2x minus 4 divided by x squared plus x plus 1 dx. What is this? The integral here, so the derivative of this denominator will be 2x plus 1. But here is 2x minus 4. What we are going to do is to add and subtract 5 in order to stay with 2x, so the derivative of x squared plus 2x plus x plus 1. Derivative is 2x plus 1. We need to make 2x plus 1 here. This is 1 over 3 ln of x minus 1 minus 1 over 6 times the integral. We are going to add 1 here and subtract it. Here is 2x plus 1 minus 1 minus 4 by x squared plus x plus 1 dx. Okay, now I'm going to have this. This is 1 over 3 times the natural log of x minus 1 minus 1 over 6 into 2x plus 1 by x squared plus x plus 1 dx. This minus 6, you see here, will be minus 1 minus 4, that is minus 5. We'll be multiplying here to be positive, plus 5 over 6 times the integral of the reciprocal of x squared plus x plus 1 dx. Okay? Let me hope this is visible. Now, as the derivative of this gives this, the integral must be the natural log of this x squared plus x plus 1. Here is 1 over 3 ln of x minus 1 minus 1 by 6 ln of x squared plus x plus 1, then plus 5 over 6 times the integral of a reciprocal of x squared plus x plus 1 dx. Let's continue with the question, guys. We are having okay. I'm going to let this be A. Let A be the integral of 1 by x squared plus x plus 1 dx. As you see, before starting, I told you that this kind of integrations are solved by completing the squares of the quadratic equation. Here, let me remind you the way to complete the square. If this is y can be also factoring a can be a by x squared plus b over a x plus c over a. Okay, and I'm going to assume e to be a half of the coefficient of x here. This is a half of b over a, and equal to, because you are completing the squares, will be b squared by 4a equal to. Now, we are going to complete the square. To complete the square, y can be a into x squared plus b over a, x plus equal to minus equal to plus c over a. Here I'm gonna have this. Y is equal to x is equal to a into this is the square of x plus e minus e square minus c over a, and y here is a into x plus our e was b of b by 2a for 2 minus e for 2 is b square by 4a for 2 minus c over a, nothing big. Now for our integral, let's continue by completing the squares. Here we have x plus 1. Because the coefficient of x is 1, e will be a half. Here is x square plus x plus the square of a half. Our e is a half, and e for 2 is 1 a quarter, minus 1 over 4 plus 1. Here it's, and this is x plus, we end up with x plus e, that is x plus a half for 2. This on common denominator, this can be 3 over 4. Now, in perfect squares, we have the square of x plus a half plus the square root of 3 by 2 for 2. Okay, now a is going to be the integral of 1 over this. Instead of having this, I'm going to write this. Here is x plus a half for 2 plus the square root of 3 over 2 for 2 dx. I do want to recall you the formula we use when dealing with questions like this. This is what we know. The integral 1 over x square plus a square dx is equal to the reciprocal of a times arctangent of x by a plus c. In other words, our a will be, this will be replacing x while this will be replacing a. It's 1 over the square root of 3 over 2 times arctangent of, this is x plus 1 over 2 by the square root of 3 over 2. Here is root 3, guys, plus c. This is dividing a fraction, we multiply the reciprocal. Here is 2 by root 3 times arctangent of this on common denominator, multiply x by 2. Here will be 2x plus 1 divided by root 3 plus c. That is because these two will be simplifying this. Okay, so the integral, the given integral 1 by x power 3 minus 1 dx will be equal to, we have this, and we are going to have that. That is 1 over 3 ln of x minus 1 minus 1 over 6 times the natural log of x squared plus x plus 1. We are going to add this times 5 over 6 plus 2, plus 5/6 times 2 by the square root of 3 arctangent of 2x plus 1 by root 3 plus the constant of integration. Okay, here was the question. I told you that when the denominator is a quadratic function which is irreducible, this is what we use. Now, let's try another question so that I'll be giving you some other exercises. Next to that, we'll be jumping to integration of trigonometric functions. Okay. Let's try another question, guys. I'm going to print here. If you do have any question, please let us know it in the comment sections. Okay, I see no one with question. That is good. Okay, none of you with question. Remember, our channel is Run Maths Iga Imibare. That is where you get step-by-step solved questions. Now, let's continue with another example. The example, remember, we are talking about denominator is a quadratic factor, If you didn't join our class, I recommend you to go there and join us. Okay. Some are going to be given link, especially these guys who I have their WhatsApp numbers. That's it. Okay. Let me share to them this live. Good. Okay. Before continuing with examples, let's have this. We are about to integrate the reciprocal of x squared minus x plus 1 dx. Okay. If you see this denominator cannot be factored, what we do is only to complete the squares. Completing the squares will make this question very easy. Okay. Let's complete the square of x squared minus x plus 1. This will be x power 2. Remember, to have e, we divide the coefficient of x by 2. that is minus 1 over 2. And e power 2 will be 1 over 4. That's what we are going to add here. We are going to add this e power 2. Here is plus 1 over 4 minus 1 over 4. And have this. This is going to be, we have x plus e. Remember, we take the square of x plus e. And our e is minus a half. That is x minus a half for 2. Here, don't forget to add this one. Plus 1 minus 1 over 4. This is x minus 1 over 2 raised to 2 plus here is 3 over 4. The question is somehow similar to the one we did in the previous time. Okay. This is x minus a half for 2 plus half the square root of this. That is the square root of 3 over 2 for 2. So I don't recall this. The integral 1 over x squared plus a squared. The x, remember, is the same as the integral 1 over a squared plus x squared. They are the same because addition is commutative. This is a reciprocal of a times arctangent of x over a plus c. For our question, which is a reciprocal of x squared minus x plus 1 dx, but starting by integration, this is the integral 1 over, instead of writing this, we are going to write this. Here is the square of x minus a half plus the square root of 3 over 2 power 2 dx. You see, this is of this form. That is why we are going to replace this x by this stuff, x minus a half, and the a by root 3 over 2. So the integral is going to be minus x plus 1 dx. This is 1 by, our a is this, the square root of 3 over 2 times arctangent of the x is going to be replaced by this. Here is x minus 1 over 2 divided by the square root of 3 over 2 plus c. This is multiply 2 to 1. Here is 2 by root 3 arctangent of, taking the common denominator here, is going to be 2x minus 1 over 2 all over root 3 over 2 plus c. That's why these two will simplify this one. And the integral will become 1 by x squared minus x plus 1 dx will be equal to 2 by root 3 arctangent of 2x minus 1 by root the square root of 3 plus the constant of integration. Okay. I'm going to give you guys exercise so that we'll be trying to make sure the reason was well understood. It's about 4 exercise questions. It's about 4 exercise questions. Okay. Exercises. Find A. Here is the integral of 1 by x squared plus x plus 2. The x, you see, it will be done in the same way like this. Question 2 is the integral of x by 9x squared plus 6x plus 2 dx. Remember, when you have the coefficient of x for 2 not 1, better to factorize by 9. See, we have 6x to 2 minus x minus 5 divided by x minus 2 into 2x squared plus 1 dx. Because on denominator we have a product of a reduced linear factor and irreducible quadratic equation. This is good for using this is good when using partial fraction integral. The last question, D, is the integral. We are having x minus 4 divided by 2x plus 1 times x squared plus 2. These are 4 questions you need to try, but I don't want to see if you see any challenging one among them. If it is there, please let me know it. Let me know it. If you see some challenging question, tell me and try together to make it easy. Any one of them. Because there's no comment I see, I will continue my lesson. I need to continue my lesson. Okay. Some are using WhatsApp. My fellow friends are commenting on WhatsApp. Let's now jump to integration of trigonometric functions. Integration of trigonometric functions. Integration of trigonometric functions. We are going to start from trigonometric circle.
Yes.
Starting from trigonometric circle,
What?
starting from trigonometric circle, a unity circle, have here sine, here cosine, here minus cosine, and here minus sine, here minus cosine. By the help of this trigonometric circle, the integration goes counterclockwise. It goes counterclockwise. Counterclockwise. This means the integral of cosine x dx must be sine x. Do not forget to add the constant of integration. The integral of sine x dx is the integral of sine x gives minus cosine x. The integral of minus cosine x dx, remember, I can take this minus out of the integral sign to be minus cosine x dx. Since the integral of cosine gives sine, that is minus sine. Here we have minus sine x plus c. And the integral of minus sine x dx, I can take out this minus to be minus the integral of sine x dx, and this is, since the integral of sine gives minus cosine, we have minus cosine times this minus to be cosine x plus c. Let's try to use integration by substitution on trigonometric functions. What is the integral of cosine ax plus b dx? When dealing with integrals of this kind, what do? I can use substitution, where u can be this stuff inside the cosine. Here u is equal to a x plus b. The derivative of u will be the derivative of ax, that is a, while the derivative of b is 0 because b is a constant, times the x. The next thing we do is to find dx. dx is going to be du divided by a. Now the integral becomes cosine of u times du by a. Because here is a constant, we have a out of the integral sign of the integral of cosine du. We have to integrate with respect to u, as here we have u. As you saw, we have 1 over a. The integral of cosine was sine. The integral of cosine was sine. Here is sine u plus c. So the integral of cosine ax plus b dx will be 1 over a. Because our u was ax plus b, this is sine of ax plus b. Then we add the constant of integration. We do the same for sine, guys. Let's have examples. Simply, before having examples, the integral of cosine ax plus b dx is equal to 1 over the derivative of ax plus b. So for the integral of cosine is sine, we use same stuff, and then we add the constant of integration. Really hope you are getting the course. Okay. Now, we are now going to continue with the lesson by having some examples. Okay. I'm sharing the live with my fellow friends who are listening to be my students. They are not listening to be, but they are. Okay. They are my students. So I cannot ignore them because I'm there for you guys. Now I'm so sorry a bit. I'm so sorry a bit. Examples. Examples. Let's have the integral of cosine x dx. This is a. B, the integral of sine 2x dx. C, the integral of sine x plus tan. D, the integral of cosine 3x minus 2 dx. Okay. Now, we need to continue here. For A, let me delete this note. The integral of cosine 5x dx is equal to 1 over the derivative of cosine, the derivative of sine 5x times sine of 5x plus c. This is going to be, what is the derivative of 5x? That is 1 over 5 times sine of 5x plus c. Okay. B, the integral of sine 2x dx. This is going to be 1 by 2x prime, because the integral for sine and cosine are made in the same way. Because the derivative of the integral of sine, that is minus cosine of 2x plus c. This is minus 1 over 2 cosine of 2x plus c. Okay, let's try c. We have to integrate the sine of x plus 10 dx. This is minus 1 over x plus 10 prime. Here is the derivative. Then cosine of 10x plus 10 of x plus 10 plus c. This is going to be the derivative of x plus 10, that is 1. That's why here is minus 1 by 1, that is minus cosine of x plus 10 plus a constant of integration. D, the integral for cosine of 3x minus 2 dx is given by 1 by the derivative of this stuff. Here is 3x plus 2 prime, then sine of 3x plus 2 plus c. This is the derivative of 3x plus 2, that is 1 over 3. Here is 1 over 3. Sine of 3x plus 2. Sorry, he is here plus, here was minus. Here must be minus, plus a constant of integration, guys. I'm going to give you some examples, some other examples. All, let's ignore those examples, but jump to let's jump to the integral of tan x dx. Let us make this a knot. Let's make it a knot. It doesn't matter, don't worry. Okay, what is the integral of tan x? This is the integral, tan x is the ratio of sine x and cosine x. Okay, I want to test whether the derivative of denominator has a strong relationship with the numerator. Okay, so when differentiating cosine, we get minus sine. That's why this can be minus of minus sine x by cosine x dx. Okay, since the derivative of cosine gives minus sine, the integral will be given by the natural log of cosine. So the integral of tan x dx will be given by minus the natural log of cosine x plus the constant of integration. What about that of cotangent? Doing the same for cotangent, the integral of cot x dx is equal to the integral of cosine x by sine x dx. As you remember, the derivative of sine is cosine. So, since the derivative of denominator gives numerator, this is going to be the natural log of sine x plus c. I do not want you to memorize this formula, but to know them, to know how they are proven. More generally, the integral for tangent of ax plus b dx is equal to 1 over the derivative of this ax plus b prime, then the natural log of cosine ax plus b plus a constant of integration. This is 1. 2. The integral for cot ax plus b dx is equal to 1 by ax plus b prime. Here, prime means the derivative times the natural log of the sine of ax plus b. Then we add the constant of integration. Let's have examples. Examples. We need to integrate tangent of minus 2x plus 3. For example, this will be given by 1 by the derivative of this minus 2x plus 3 derivative times the natural log of cosine of minus 2x plus 3 plus a constant. This is the derivative of minus 2x plus 3, that is minus a half, of the natural log of cosine of minus 2x plus 3 plus a constant. What about the integral letter cosine of cot of 10x dx? This will be given, but here for tangent here must be minus. That's why here must be minus. This to be positive. This is gonna be 1 over 10x prime times the natural log of sine of 10x plus c. This will be 1 over 10 natural log of sine 10x plus c. Okay. Let's jump to integration of some forms where we have the product of two sine functions, the product of sine and cosine functions, and the product of cosine and cosine functions. Okay. Integration of the form. Integration of the form sine mx cosine nx dx, sine mx sine nx dx, and cosine mx cosine nx dx. We are going to deal with integration of these forms. As you see, it's very easy to transform those products into their corresponding sums. What we need is to transform sine mx cosine nx in sum. Transform sine mx sine nx in sum. Transform cosine mx cosine nx in sum. Okay, that is how to deal with integration of these forms. Okay, hope you remember that sine a cosine b, this is a half of the sine of a plus b plus the sine of a minus b. Is here plus or minus? Is here plus or minus? Okay, here is plus. While cosine a cosine b is a half of cosine a plus b plus cosine a minus b. For sine a, sine b, this is minus a half of cosine a plus b minus cosine a minus b. Hope these are the formulas. Okay. Now, for sine mx cosine nx, this is a half of, we have sine where a will be replaced by mx. Here is m plus n times x plus sine of m minus n x. For cosine mx cosine nx, this is half of cosine m plus n times x plus cosine of m minus nx. Sine mx sine nx will be writing as a sum as the cosine of m plus n times x minus the cosine, here is minus, of m minus n x. This is how we do it. So let's now have some examples. And in my site, This is sine integrals. These trigonometric integrals are looking easy, and there is nothing challenged in them. Let's have to at least 2 or 3 examples. Let's now have examples. Examples. Example 1. The integral cosine 3x sine 5x dx. This is cosine A sine B. And here we have only sine A cosine B, but they are done the same way. You know, multiplication is commutative. Here we can start by sine 5x cosine 3x dx. What we need to do is to transform sine 5x cosine 3x in a sum by using this formula here. This is going to be a half of sine half this plus this 5x plus 3x, that is 8x, plus sine 5x minus 3x, that is 2x. This is enough. This will be a half of sine 8x plus a half of sine 2x. The integral, instead of writing this, of cosine 3x sine 5x dx is equal to the integral of a half of sine 8x dx plus the integral of a half of sine 2x dx. As I told you, when having a number times a function, we take it out of the integral sign. That's why this is going to be a half of the integral of sine 8x dx plus a half of the integral of sine 2x dx. We saw that the integral of sine ax plus b dx was 1 minus 1 over the derivative of ax plus b, then cosine of ax plus b plus c. So the integral of cosine 3x sine 5x dx will be equal to, we have 1 over 2 times the integral of this will be having the derivative of 8x, that is minus 1 over the derivative of 8x, that is 8. Here is 8 cosine of 8x plus a half of, we are going to have minus 1 by the derivative of 2x, which is, what is the derivative of 2x, guys? That is 2 cosine of 2x plus c. Now the integral will be minus 1 over 16 cosine 8x minus 1 over 4 cosine 2x plus c. We can stop by here. Okay. The next is about, let's have sine 3x, sine 3x. Okay, example 2. We have sine 3x, sine 3x, integral dx. We know is sine mx, sine nx. That is minus half. So we need to transform sine 3x, sine 3x. This is minus 1 over 2 into, we'll be using this formula. That is cosine 3x plus 3x, that is 6x, minus cosine of 0 up here is going to be 3x minus 3x, that is 0. This is minus a half of cosine 6x. Remember, the cosine of 0 is 1. That 1 minus 1 will be multiplying this to be plus a half. So the integral will be, we are going to integrate this. Remember the integral of cosine, that is cosine 6x, that is 1 over 6, and 6x, 1 over 6 will be multiplying here. That will be minus 1 by 12 cosine, sorry, here is sine 6x, but plus the integral of a number, that is that number times x, plus a half of x, plus the constant of integration. Second example, the second example, we have sine 3x, sorry, sine 3x cosine 3x dx. Because here is a product of sine and cosine, we need to transform sine 2x cosine 3x as 1 over 2 into sine 2x plus 3x, that is 5x, plus the sine of 2x minus 3x, that is minus x. This will be 1 over 2 sine 5x. Because sine functions are odd functions, this is going to be minus, the sine of minus theta is the same as sine theta, minus sine theta, sorry. That's why this is minus a half of sine x. So the integral will be, the integral is going to be the integral of 1/2 sine 5x dx minus the integral of 1/2 sine x dx. This will be a half. What is the integral of sine 5x? That is minus 1 over 5 cosine times minus 1 over 5 cosine 5x minus 1 over 2. What is the integral of minus sine or of sine? That is minus cosine x plus c. That's why the integral sine 2x cosine 3x dx is going to be minus 1 over 10 cosine 5x. Here minus half times minus, that is plus a half of cosine x plus the constant of integration. Okay, let's continue with the questions, and they're going to be left as your exercise to try. Okay, exercise. Find a the integral of cosine squared x cosine x dx. You remember that cosine square is the product of cosine and cosine. That's why this is simply the integral of cosine x cosine x dx. You need to transform the first two in sum and then multiply the second. Multiply cosine x in that sum. B, we have the integral of cosine x cosine 7x dx. C, we have the integral of cosine 3x cosine 3x dx. D is about the integral of sine x cosine x dx. Those are the integration that those forms. And let me add another question. The integral of sine x sine 2x sine 3x dx. This will be the last question will be done the same way as this one. A, you will have to transform this in a product. After that, we'll be having sine times that sum, and then you will again transform the product you get into sum. Okay, now we are going to continue to the unity where our class will be ending to. We will, on the press layer, we transform the product into the sum to get the easiest way of finding or evaluating the integrals of product of sine and cosine functions. So let's continue with integration of the form sine to the power of mx cosine to the power of nx dx. Okay, how do we deal with integration of these kinds? Okay, now let's have two notes to follow when dealing with the integration of that form. Okay, When m is an odd number, when m is odd, please save one factor of sign. Save one factor of sign x, and then use the identity the identity sine squared x, which is 1 minus cosine squared x. This is when the power of sine is odd. What if the power of cosine is odd? When n is odd, the power of cosine is odd. Please save one factor of cosine x and use the identity cosine squared x is equal to 1 minus sine squared x. Okay, let's have examples, guys. Let's have examples. Example 1. We have sine power 3x cosine power 2x dx. As you see, the power of sine is odd. That's why we are going to save a factor of sine x. We need to save one factor of sine x. This will be the integral of sine x, sine squared x times cosine squared x. Then that factor can be written before dx. See the small change in x. Okay, because we are here, this sine squared is going to be transformed as 1 minus cosine squared. Hope you see that. Now, here is 1 minus cosine squared x times cosine squared x, then sine x dx. Okay, now the next thing is to assume here add assume u to be cosine x. Here you will assume u to be sine x. Okay, now let u be, because here we have cosine and we save the one factor of sine. Here u will be assumed to be cosine x. The derivative of u, let me write it here. The derivative of u, what is the derivative of cosine? Guys, that is minus sine x dx. So multiply minus both sides, or take this minus here to have the u. This is sine x dx. Now we have this. This will be replaced by minus the u. Okay. Now we have 1 minus u power 2 times u power 2 du because here is minus, let me take it out of the integral sign. This is minus. I am going to multiply this u power 2 inside here to have u power 2 minus u power 4 du. You know the formula where the integral of x power n is equal to x power n plus 1 by n plus 1 plus c. That's why this will be minus, because here is power of 2, we are going to add 1 there. That is u power 3 by 3 minus u power 4 by 4 plus c. Okay. Now, the given integral, we will have sine power 3 of x cosine squared of x dx. This will be minus, what is u? U was cosine x. Here is cosine power 3 x over 3 minus cosine power 4 of x over 4 plus a constant of integration. That constant can be any number of your choice. Okay. I'll be giving you some other case, but after this example. The second example is about, let's have sine 3x cosine power 3x dx. You see, both of them, both m and n are odd. That's why I can use this to save a factor of cosine, or use this to save a factor of sine. This can be the integral of sine power 3x times cosine squared x times cosine x dx. This works. So, because here I have cosine power 2, I'm going to use this identity where cosine squared is equal to 1 minus the square of sine x. Okay. This will be sine power 3 of x into 1 minus sine squared x. We have saved a factor of cosine x dx. Now, let's use u, where u is going to be sine x. Here u is sine x. Du will be cosine x dx. As you see, all of this stuff will be replaced by du. Now, the integral will be u power 3 into 1 minus u to 2 du. This is u power 3 times 1, that is u power 3, minus u power 3 times u power 2, that is u power 5 du. Okay, and that is, remember we add 1 here, we have u power 4 divided by 4 minus u power 6 divided by 6 plus c. And just to remember, our u was assumed to be sine x. No, here is x, not u. So the given integral sine power 3x cosine power 3x dx is, as u is sine x, this is sine power 4 of x by 4 minus sine power 6 of x over 6 plus the constant of integration, guys. Next, let's try the last. Sine power 3 x dx. Even here, because the power of cosine is 0, even here, we can save one factor of sine. That is sine squared x times sine x dx. And this must be, as we save a factor of 1 minus cosine square. Here, sine squared x must be replaced by 1 minus cosine squared of x. This is 1 minus cosine squared of x times the sine of x dx. Using u sub, let us assume u to be cosine x du will be minus sine x dx. Because here is minus, let multiply this minus here to be minus du will be sine x dx. So all of this will be replaced by minus du. Because we are multiplying by minus, let's take this minus out of the integral sign to be minus 1 minus u power 2 du. This is minus the integral of 1 with respect to 2, that is u, minus, we add 1 here, u power 3 over 3 plus c. So the integral of sine power 3 x dx will be minus, we have u was assumed to be cosine, here is minus cosine u, minus cosine power 3 of u over 3 plus c. Now this is my time to leave, to let know for you and leave some exercise. But before exercise, not. Remember, we are on sine power m x cosine power n x dx if both m and n are even numbers. Here we use the so-called linearization. Use linearization where cosine x can be replaced as by exponential of ix minus is here minus plus exponential of minus ix by 2 and sine x exponential of ix minus exponential of minus ix by 2. Guys, I'm gonna leave you some exercise so that next time we'll be continuing with this integration where both n and m are even numbers. Okay, let me give you some exercise. A, we have cosine power 3x sine x dx. B is about cosine power 3x sine for 3x dx. C, we have the integral of cosine for 3 of 4x dx d. We have the integral of cosine for 3x sine power 5 of x. Because here is 2x, not 1x, 2x, and here 2x dx. The last one is E, the integral of sine power 4 of 2x cosine of 2x dx. Thank you very much for being with us. Next time we'll be continuing with this. If you didn't subscribe to my channel, please go there and join me. Make sure that your like is very important.